Alright, welcome to another video on our Formatables refactor, part 10 now I think. So just after the last video, we didn't do any recording for this, but we started to introduce some of the types that we're going to need. So let's just see where we are then. Here in... There we are. So we added all the types here for the header guard, inclusion path. This may have actually been part of the last video, not too sure. Generated all of that, and then as we were about to try to update or populate the header guard and inclusion path, we realized that at present, let's just recap that. So at present, the way that the inclusion path works is by asking the formatter, the text transform, for the inclusion. No, actually, these are the inclusion dependencies. So there's two aspects to this. Presumably will be in the directive group. Right. Yeah. So there we are. So on the directive side, we check the status of the text transform, whether it's got canonical support or not, and whether it requires a header file. And the problem we have at the moment is that we can't do equivalent to this in the new world. So in the old world, just to recap, what we used to do is we used to go to each text transform, and if I have a quick look, say at one of these text transforms here, you can see that the text transforms via the magic of templates contain a whole lot of methods here related to inclusion. And the new world, all of this becomes data rather than being part of the text transform. So what we really want is to make use of the data that we supply when we generate any metamodel element of type text transform, what we call an archetype, and we don't really want all of this to be sort of bound to the template itself. So we've done half of that work, to be fair. We already, if I take a text template, you can see that we already have a property called relation status, whether a template is where an element is relatable or not relatable to another, and that's modeled in the physical model. And around here, so as you can see here, we already have all the relation status and the different kinds are all modeled here. So it's all very nice and fine from a meta model perspective. We just need to get that information to the model, the physical model itself. So what we did is we generated a transform to do just that. Of course, it may be a bit confusing that we already have another relations transform somewhere. We don't yet, but we will soon. But that will be the meta model relations, and we can't really do all the relations just yet. All we just care about is this relation status, which will enable us to progress. So, all this to say that we need to go to relation status, to relation transform, which is here, which we have a skeleton for. And now what we need to do is we need to obtain the PMM. Presumably the context will have a PMM. Let's have a look at the context. Meta model, presumably. So this should be the PMM, and then if I am right, let's just give a reference here to types meta mod, presumably, and Dogen physical entities meta model. I think this is just LSP. Oh yeah, LSP was just a bit slow. Right, so then we'll have backends, and then in each backend we are going to, so if you know where we are now is we are somewhere somewhere around here. So a backend, so this guy here will contain a list of backends. Each backend will then contain archetypes, and the archetypes are also part of the parts. Now I think we need to expand every single archetype that exists in the backend. It's not very obvious actually how this is set up, because facet contains archetypes, the backend contains archetypes, a part contains archetypes. Now it's not very clear if I ask for the archetypes at the backend level whether I'm going to get all the archetypes of that backend or only the archetypes that belong at the backend level. So I'm just going to assume and see what happens. Assume that they are at the backend level. May not be correct. So what we want to do is we want to look at every archetype in every backend, and then for each archetype we are in the physical model. So now this is where things become a bit tricky, because we need somehow to map between we need somehow to map between the regions. These regions are all organized by logical ID, and we can have many instances of the same archetype. So really, let's just do a two-pass process really. We probably can get away with just something like, let's first grab all the relationship stuff. I mean, we already know what we want. We want the relations. So we could basically say relations for each meta type. I mean, we could, of course, at this point you could say, why don't we just index this stuff? I mean, we already have indexed names. You could easily have indexed relations just to quickly grab them. I'm going to resist that temptation for now and just create a simple container, and that container will be populated like so. So let's just say that this guy here is updates the relation information in the physical model for now, and then in here we could do something like let's think about this. Starters will need relations, clear. And we could say something like std unordered map of entities physical, actually identification, of course. So if we go to identification and then say something like so a physical meta ID presumably, and here we could say relations or entities relations, right, something like this, right? It's interesting. It seems to be trying its best to give us the right includes. I don't like the order, but this is doing the right thing. And then so get obtain relations for archetype, and for that we probably need a meta model. Right, so now if I just say to you, please this is the physical meta model, this could be static so we don't have to worry about state, and this would create indexes, relations for archetypes. Right. So very simple. This could, of course, this is code that's actually going to stay. So at some point we'll have to tidy this code up, but for now, this could be sufficient. I'm going to try to see if I can simplify this slightly. Right, so if we start to populate our little container, and something not quite right with our spacing here. I'm not quite sure, but so let's just see what happens. For const outer by reference backend in pmm.backends. No, nope. I think we have too many things enabled at the same time. It's not entirely obvious why Emacs is convinced that it needs to give us additional space here. That normally is a sign that we've made a mistake somewhere, but can't see any indentation errors for now. We probably need to just reopen this file, I think. Right, so then, if we then say something similar to, let's think about this. So, archetypes, perhaps. Backend.archetypes. And in here, we can just do something like insert, and what we want is the archetype dot. Okay, this is actually a pair. And then we could just say archetype dot name, presumably. Meta name .id. So we can make a pair. We need another pair here. So this is probably the archetype pair. And this could be so if we just make a pair. With the ID and the archetype dot relations, presumably, and then we could say insert the pair, and remember if it did get inserted, and if it's not inserted, we'll throw. And then we can simply return the results. Right, so this is where the problems are coming from. And that's why our thing was not correct. Okay, so that's not too bad. So now then, we don't really know if this is going to be the right thing, but it seems to more or less be grabbing all the relations for a given archetype, more or less. And if we then say that, let's say we use one of these guys here. You can clearly see this is a very common pattern we have in the whole of the Dogen code base. We're desperate for some code generation for this. To really, in C# terms, we'd call this an extension method. Really, all we need really is an extension method here. Right, and the transform exception. Righty, so I think this gives us sort of a good starting point. And if we could then say something like const auto, let's call this a relationship for archetype, and then I supply you with a PMM. And now I could very simply do something like region. I suspect this is actually a pair. And then if I just do auto by reference region pair seconds. Right, now I have a region, and then in this region all I need to do now is to say for auto by reference. Now what is the container inside of the region? Archetypes, artifacts by archetype, right? So presumably that's a pair. This would be our arc pair. Right, now then, we have our archetype. Let's go, this is going to be a pointer. And now we could do something like this. Of course you can imagine this is ridiculously expensive because we're going to go all over the place. We're going to, per archetype, we're going to be looking for its, per artifact, we're going to be looking for its archetypes. So we shouldn't really call these archetypes. I think we should be calling them artifacts. And this is an artifact, which we tend to call A. So now I have an artifact. Now you can imagine this is obviously not very nice, because what we're going to be doing now is we're going to be saying, in fact we already have the artifact ID, so if I just to say something like so PM ID, physical model ID, and that's going to be obviously the pair. But first, as you can imagine, and now what we're going to be doing is we're going to be saying, well, please locate on my relations container the PMID, and clearly we do not want that PMID to not to be found, because that would mean there's some kind of really weird inconsistency in our model. So it must exist. Okay. Something like this. Once we got the relations, then we can do something like a dot incomplete type, no problem. Let's make sure everything's okay. Can you hear that nice and downstairs? Okay, just a noise going on. So what we need to do is to obtain the artifact, look for... interesting, I thought we'd have some properties to do with relations in the artifact. Perhaps we forgot the obvious thing to do, which is to add the relations property. So we add relations with properties but not an attribute to store the relations. So that's quite hilarious. Oh no, what's this? So yeah, as you can see here, we do a schoolboy error. So we need something for this guy. Right, now then. So we will have to generate these types. Sure, we've converted this recently. So this will be all artifact related stuff, that's fine. We will commit this in 1 second. First we just need to see what the relations, Now, these relationship properties are completely different from the relations that we got in meta relations. But there is one thing we're interested in, so I will just say relations dot relation status, and in here we can say that there's the meta relations. We should probably really call these things meta relations, but there you are. And I could just copy across the status. In fact, we should probably name this correctly. It's not very nice to have the same thing named differently in different places. While we're there, Dia seems a bit slow for some reason. I must say this new version of Dia is a lot less stable than a good old 10-year-old version that we used for many years. Right, there we are. So what we'll do is we will do both of these updates in one go, since we're changing the model. And that should hopefully. Right, so we just need to look for relation properties. Relation properties and relation properties. And that's all transform stuff, so that's fine. And if I now attempt to run all tests, with a bit of luck. Oh, of course, we just changed that. Oh, not quite what we meant to do. Machine is a bit slow, not entirely sure why. I wouldn't have thought it would be that busy. This is a pretty beefy machine, so you wouldn't expect compilation to cause that much havoc, but there you are. Right, he's going to go away and do his thing. We'll leave it to it. So what we expect to see with all of this stuff is that now we should have the relation status available by the time we enter our legacy path transform. And once we got that, hopefully that would mean that we should be able to. I go back to my Directive Groups repository pattern. So if you look at this transform here, we pretty much have got all the bits that we need. The inclusion support type is the now called relationship status. We have all this stuff to compute the primary directive and secondary directive. We need a little bit of fiddling with the features. We haven't actually done that just yet, which makes me think somebody must be declaring these features at the moment. So we're looking for primary inclusion and secondary inclusions while we wait for the codes. So let's have a look at who's responsible for these features right now. Inclusion required, that's one of ours. However, I can't see anything but primary and directives here. A bit puzzling. Somebody must be responsible for this. One of the problems we have at the moment with features is that it's very difficult to figure out what the features are. Let's have a look here. I don't think we moved them already. And we haven't. So it has to be here somewhere. Another disadvantage of having diagrams is that search is not particularly brilliant, so we can't really see who's declaring these features. We can. We are just not looking properly. So we decided to use a feature template bundle for this. Now let's try to understand a bit better what this is trying to say to us. This is okay. That kind of makes sense. We are expanding this template across all archetypes in C++, which is fine because it's only a C++ thing. But interestingly enough, that would then mean that when we're handling this situation, we don't really know whether we're in C++ or C#. So if the feature only exists for C++ archetypes, we just have to make sure we handle correctly the case of C# archetypes. I think that's probably fine. Let's see if there's any equivalent machinery for C#. Don't think we do have it. Doesn't look like it. Right, so then, and also we have the interesting case of the global feature here, and then the local feature. So it would be nice if we could just have both in one go. I wonder actually why inclusion required is a global feature. It binds on an element. I'm not entirely sure I understand how this was done, because this is not really global in the sense that this is not just one feature per model. This is in fact very much not global, it's local. I mean, these are global. Standard, yeah, you set the standard just once. But pretty much all these other features here are very local to the element. So I think when we call these global features, we're kind of lying slightly, because I think what's happening at the moment is, and on top of that, notice also that we are not generating the static configuration. Okay, that's fine. So I suspect that all of these have got different binding points. Yeah. So this is extremely misleading, but that's not a problem. We now know what we're dealing with, so we'll sort that out. Okay, so let's have a quick look at what's going on here. Right, what we can see here, well, let's just separate this into two things. First thing is we have done some changes to the physical model. Add relation attribute and rename relation artifact status. Okay, so these are two very simple changes that don't really require a lot of thinking. We know those are good. However, problem is we seem to be missing a whole lot of archetypes. Now I think the reason why we're missing a whole lot of archetypes is very simple. It's not that we're actually missing them, it's just like I said, I think what is meant by archetypes is not really archetypes, but it's just the archetypes in the backend level. So we need to continue and press on. So what we need to do is to say, okay, that iterates the archetypes at the backend level, that's fine, no problem. Now please can you also iterate through in fact not quite at that level but at this level, forecast outer by reference facet va dot facets. Now that's going to be a facet pair, and then const auto by reference facets second, and then if we just find the archetypes, which will be in facet dot archetypes, and then presumably We need the similar logic to what we've done here. It's a bit of a quick hack for now. Can fix this in a minute. We still expect there to just be one archetype for that ID. So that handles the case of facets. We can very much copy and paste. I mean, clearly by now we've already figured out we should probably have a function for this, but there you are. So if we do something very similar to this, that will grab all the archetypes in a part, if there's such a thing. I thought there was, maybe I'm lying, there is. So that's correct. Okay, so that grabs all the archetypes. So we grabbed the archetypes at the backend level, at the facet level, at the part level. I think that's pretty much it, really. That's probably going to solve our problem, I think. And if we then just run the tests again, hopefully the meta model will be consistent. Now we expect every archetype to be defined, so they have to exist somewhere. They do exist. Right, cool, that's great. So now we've captured all the archetypes, we put them in the right places. We also know that we have gone through all the regions, and in each region we then updated the relationship status according to whatever the archetype is for that artifact. So we could say implement the relations transform. Now that clearly you're going to say there's lots of cleanup that needs doing here, but we do this in passes. First pass is just to see if this does anything vaguely sensible. So what we really care about now is to see if we can populate the other bits of data. So let's just start by solving that issue of right, so let's have a look at this. So let's have a look at what features we already got at the physical level. So we have archetype features. That's very interesting. I think probably we should have called them archetype file system features or something like, because we need other kinds of archetype features, but I mean we could put them there, but the problem of course is you don't really want to bundle features that are not going to be used together. So it makes no sense for us to have archetype features and then those archetype features to be used in two separate cases, because then you can't really validate very much that way, can we? It makes more sense to have two different types of bundles of features that are used separately. And in reality, really, if you think about it, what we are saying here, in fact, to be honest, what we are really saying is that there isn't three of these things, there's only two. There isn't two of these things, there's only one. So these three things should go together. Inclusion required, primary inclusion, secondary inclusion. So what we'll do is we'll copy this guy here to the physical model. Paste that there somewhere. Remember that we can't really paste properly in Dia, so sadly we need to copy things across. And then what we'll do is we will give it a name. And that name could be inclusion features. Sounds vaguely sensible. We'll let that set of features still expand across the space of archetypes in C++. I'm not entirely sure what happened there, but try again. And then we could say, well, actually, to be fair, we'll probably start with inclusion required chap. And I guess this is where two windows of Dia would be useful, so we don't have to be opening and closing things every 5 seconds. There you go. And value, very important. It could break lots of things. It is exactly in these copy and paste exercises that a lot of time is wasted due to very minor mistakes. Right, so now we have the inclusion feature. Now you have to make sure that these features are consistent now, because they were not designed to be used together originally. So you can imagine these guys here were part of a template expansion and the other ones weren't, so we just have to do a couple of fixes to get them to work together. Right, see, we don't really need this guy here, and these are correct. So that's the domain. Interestingly enough, one thing that seems to be missing here. Oh no, because it will instantiate. So okay, I think this should do the trick. Now, what's going to happen, of course, is that once we try to generate these features, we will cause a problem, because, as you can imagine, we are already generating them here. So what we probably need to do, we don't really want to lose okay, there's something interesting here, which is inclusion required. Right, so there was slight difference of approach, right? So inclusion required was not a template, so that basically means that we would type something like mas.cpp.inclusion required, and that was available in every single element. The archetype features, however, those were templates, and so in these cases you would type something like mas.cpp.archetype name.primary inclusion directive. Why we took that different approach for these two guys is not entirely obvious. Really? But, however, we did, and this now means that if we're not careful, we're going to break the world, because if I now have a quick look at one of the existing PDM models, like Boost, for example, see, as you can see here, these guys have primary inclusion directive. Oh, yes, that's because, of course, we want to, oh yes, no, it makes sense, it does make sense, it's correct. We need one of these per archetype, whereas inclusion required, actually, we just need one at the top level. So if I take a built-in, and if I look at inclusion, good type, you can see here the built-ins will have inclusion required set to false. So this is not going to work. It's not going to, I can't group these two things together, and that is correct, sadly. So let's just go back to physical again and say, let's call these directive features, and I think that will be fine. And then here let's create another one, which we call the inclusion. I mean, clearly this is all becoming a bit messy, but the key thing, and I'm sure that you may be thinking, oh well, this is a little bit haphazard, we're just adding a lot of stuff very quickly without really reflecting on this. Yeah, of course, if you were working on a development team, a normal development team, lots of developers and plenty of time, you would, for each of these changes, we'd be thinking very carefully about what you're going to do, how you're going to do it. But when you're working on your open source project on the side, there is no such time. So what you need to do is you need to make sure you can just move from one step to the next step. And sometimes it may mean you things in a bit of a haphazard way, but hopefully the end destination, the thing you're striving towards, is slightly more interesting. We have two different colors here. one for the templates. Okay, so this should have been CCE, and that should have been the BAD. Yeah, so as I was saying, yeah, you wouldn't, in a normal code base, be doing these kind of changes this quickly without reflecting quite deeply in what you're doing. But if you were to do that on your open source projects, you would struggle to actually get anything done, because you only have a certain amount of hours every week, and they keep on resetting state. So instead, the better approach I found for this kind of projects is to actually keep moving, even if you're not entirely sure if something is the perfect decision or direction, but just keep going, even if there's a lot of hackery in the middle. The general direction is the right direction. That's the key thing. So there you are. We have inclusion features now. Inclusion features are no longer a template. They're not expanding over the space of archetypes. They're just going to be global. Of course, now we need to go back to this guy here and make sure that we correctly mark it as a binding point. And that will be in here. And so now we, in fact, I'm just going to move these two like this. So now we've replicated the approach there. The directive features are expanding across the space of archetypes. The inclusion features are not expanding, so we just have one at the top level for that one element. So it's global to the element. It's really not global in any way. And when these things kick in, they will cause a duplication because they also exist here. So what we need to do now is to get rid of these guys here and generate everything. And if we did not break anything, well, what we would expect to see, I'm just going to do both JSON and what we would expect to see now is of course, one thing we must remember is that we have changed this text.cpp model as well. Right, now then, let's just move the features from one place to another, and if everything has gone according to plan, I'm sure it hasn't, but in theory this should not cause any problems. It should still initialize the feature, just in a different place. Okay, that's correct. Okay, so that's good. Let's make sure this code generator still generates. So all we've done is we relocated the feature from one model to another. Nothing particularly bad should happen. So move inclusion related features from text.cpp. Okay, that's pretty cool. That all worked as expected. And now that we have those features there, what we need to do now is we need to try to figure out what the directive repo was doing. Again, I'm not going to be very creative here. I'm actually just going to copy and paste. You could blame me for that, but as I keep saying, the objective of this is just to get us to the next step. One annoying thing we have at the moment is this. No, why do we have a libxml include that one there? Don't think we need that guy. Sadly, with all this cleverness of LSP, sometimes we do the wrong things. So variability should go first, then physical. Okay, now then. Now let's just say that we take all these features here. Now we don't need to rely on these guys, I think. We could just rely on the generated code now, I think. Except. Yes, we have a slight problem here. yes, we probably need to disable static generation. I think that's probably what we've done here. Yes, exactly. So these are very special cases, and I think we didn't even have those for the templates. So what we're going to do is just go back to the physical model and say, actually, don't bother generating code for the static configuration. And I think for templates, I don't even think we need to bother with that, because I think for templates we just, it's not even possible to do very much with that. Some work still needed there. So in theory this should not cause any problem again. Let's just convert and indent. So this will remove a whole lot of code generation that we do for to help things out, so we can read the features from the object. But we haven't had the time yet to handle some of the corner cases of features. Certain times we know exactly what needs to be doing, but it needs to be done, but we just haven't had the time. So we can just say remove static configuration for inclusion features. Right, now then, because we removed those guys, we need to now do them manually. And I think we're going to find that most of this will be direct copy and paste, but right, so we are creating a feature group. Yes, okay, so this we can't really just do this without thinking. Let's see what we're doing for time. 47 minutes. Okay, so we can't actually just copy these guys across without thinking, because things like Directive Group don't exist anymore, and the formatted repository. So we need a little bit of thinking, not a lot, but a little bit. And let's think about this then. So we still need the feature groups to have more or less the same shape. Perhaps we shouldn't really call this formatted feature group, but archetype. And that will contain on a per archetype basis the feature group. And the inclusion required will be there too. So that's good. Now, how do we create the feature group? We need to supply something from the PMM. Presumably some kind of index. And I think we got just the guy. Yeah, let's just use the index names, because I reckon this will give us what we need. And for that, we will need some include. Interestingly enough, it doesn't seem like we got that for free. Right, so this guy will expand the feature groups across the index physical maintenance phase, and then where things become interesting is where we try to make a directive group. So we probably want something like instead of a directive group, let's have a look at what a directive group is. So directive group gives us the string and the list of properties that we're interested in. We could, of course, create a directive group. Nothing stops us from doing that. However, before we had a proper purpose for it. Now we are just going to take that information and slot it into this guy here. So I think we're probably better off, actually, excuse me. A cold coming, I think. We probably could, actually. Change the logic slightly and say something like update read directive properties, read inclusion properties perhaps. And interestingly enough as well, we don't seem to be reading the inclusion required, so I'm not totally sure what we're going to do here, but let's just hold on there for a second. So you see here, what we're trying to do is we're trying to figure out which formatters don't have requirements for inclusion, which is actually quite an interesting thing, because we could do something similar. And then we organize them by meta name. So that by the time we are going to query the formatter, we are ready with the right information. But we don't need to do much of this, because remember, we've copied the relationship status now over to the relation inside of the archetype, so we don't really care about that so much. So it would be nice not to create feature groups for formatters that don't really need it. We are going to create a lot of feature groups here that are completely irrelevant. But let's just ignore that for now. This is all temporary code anyway. And then we probably need the logic for the inclusion directives. Okay. Yeah, I kind of need half of this transform, but not all of it. It's a bit confusing, really. I think we just need to actually get cracking with the coding to make this a bit clearer. So we started trying to do the relative path to the archetype, and got a bit stuck there, because the problem with the relative path to the archetype is that we need to know the relationship status, or the relation status. So we got that now, but we also started handling simultaneously the directive stuff. And I think what we probably should do is we should probably say something like for each archetype, update the directive properties, I think. Yeah, that's what we're going to do. So instead of making a directive group, we're going to say something like void update inclusion properties. Path properties. Very quite a line of noise downstairs. 1 second, please. Okay, so so the idea now being that what we're going to do instead is we will give you the feature group, which is fine. Probably will give you, well, let's think about this. You are iterating through the archetype. You'd have a configuration to read, but clearly it makes more sense for me to give you, so if I say something like physical entities artifact, and perhaps the artifact won't have a configuration, I don't think. What does an element do? It is configurable. Okay, so it does have a configuration, so which then means we don't need this and this. So the idea then being that we first create the features, And then per archetype, we will go and update the inclusion properties. Now, of course, you may say, well, if you're going to update the inclusion properties, sorry, I think there's some noise coming from downstairs again. Got a lot of chatter going on downstairs, I'm afraid. So we should be able to update all the inclusion properties from here. Format not found for type, method type. And then, of course, one has to be slightly careful that we still need to handle all of these permutations. Interesting that we bothered to say as inclusion overrides, and then seems a bit silly that we bother with that. Why did we do that, in fact? Because if there isn't any overrides at all, we could, yes, okay, we can simplify things quite dramatically. It means we don't have to bother going through creating a directive group and so on, right? And then life is much more complicated with all this stuff. Okay, so perhaps I changed my mind actually. Let's go back to the way things were. Let's attempt to create a directive group. And the reason why is because I think in fact we could just make a struct here. So if we go this way, I suspect we'll have an easier time. So I'm just gonna make a very simple version of a directive group. We don't really need all the elaborate class level. Well, as you can see, this directive group is really, really simple. It's just a simple struct, and we'll get all the information that we need. So with this, we preserve most of the logic. I can still hear some noise. Okay, so now then, where things become a little bit tricky is we definitely don't need all of this logic. We probably could do with 2 inclusion directive. That will be useful. But we don't really need insert inclusion directive, I do not think. Because I think insert inclusion directive is going to populate the repository, yeah, as you can see, with directive groups, and we don't really have that equivalent. So we changed completely the model, the way that the data was being modeled. So that's not going to help. Some of this logic will be good, some of it won't. So what we'll do, just to avoid confusion, one second. Just to avoid confusion, what we'll do is we will take the bits that we think works out of the box, which is already quite a fair amount. As you can see here, we have a lot of hackeries going on here too. Not all of it being used anymore, it seems. Don't have to copy across the stuff that's not being used. That is. think we've already copied some of this stuff. Well, to be honest, what we'll do is we will take a few of these guys, see what breaks, and take it from there. Which is fine. So you have to remember we already have all the hackery around the locator. Mustn't forget that. And this will be some other hackery. So what we want to do is we want to say wherever we had one of these, please oh, sadly I can't actually paste annoyingly. So what is the name of the transform? Legacy fast transform. Right, so now then, let's just get this code to compile. We probably need most of these guys. Few duplicate ones. To the point where it might be helpful to use hide show mode, because you get so much stuff in this header file. Impossible to see the width of the trees. Right, so we're trying to create the feature group. First thing is we don't really have a repository, so let's go for our index. That looks good. And then we don't really want to be using traits. Now, I'm not entirely sure why we did not create. So when we disable the static generation, let's see what we disabled. Now, for the top level one, funnily enough, we probably didn't have to disable that, but we did, so let's just not worry about it. So there'll be traits class here, one of the really worstly named classes in Dogen, and there's quite a few fighting for that title. Interestingly enough, there we go. A cough today, I'm afraid. Okay, so we have inclusion required here. And interestingly enough, you can see what we've done here. We tried to filter immediately those artifacts which needed but we're not going to do that. So what we'll do instead is we will say im.metanames. So archetype name is biological metaname. I'm actually going to go as far as saying perhaps all. I suspect. But I wonder if all means all archetypes, or let's go to identification. What does all mean? All metanames. I think it's really not all metanames, but all archetype names. This is a bit misleading, really, because it's not clear what all metanames these are. Just to be on the safe side, we're gonna chicken out and actually go for the archetype names biological ID, I think. Biological metaname. and this will give us a pair. And the PMN is now going to be something like for well, first probably we should do what is that container gonna have a list. So maybe something like pair not second, and then if we just do something like const out of our reference. Not ideal to have a cough while trying to record something. So hopefully hopefully this will take us somewhere. So sure why the meta names. Oh, this is an archetype name set. So in this particular case, we want to do something like meta names. Now we have no way of knowing whether these archetypes support or not inclusion, so there's that. And we need to access the archetype. And in here we need to access these guys here. So for the primary inclusion directive, we can just take this. In fact, we can probably take the whole string. And we can then say, well, I'm not sure if FG is the right thing. Something like this, and then we can say AFG. For the secondary inclusion directive, similarly, we could take this guy here. These are both consts, really. Okay. We have a return type. Right, okay. So what we've done then is we've managed to just about obtain all of the bits that we need to for the features, which is good. Now need to address the transform errors. I think that's about right. It looks a bit better. Okay, so now let's see what we do here. So let's say I have a primary. Now this is a struct, so it'll be very straightforward. And we populate it with that, and nothing. Okay, cool. So that's actually slightly surprisingly uncontroversial. Though Enoch seems to be thinking about something. Now, what is an override port? Oh, I would probably need the Directive Group repository. Here we are. Put this guy here somewhere. Right, area. So up to now, this was surprisingly easy. So these methods are all reading all the metadata that we got initial element type. They are kind of lining things up, I guess, for our second step. The second bit is going to be slightly more controversial, I'm afraid. We now have a completely different data model. So in order to map the new data model to the old data model, we need to do quite a fair bit of thinking. So we're looping through the artifacts, and per artifact, well, presumably the first step will be actually quite uncontroversial, because probably we need to obtain the features. So I suspect this will be very straightforward, and we could just do it here. We could say something like context dot meta model dot let's just get access to the PMM first, I think. So that's the PMM, and then we can just say PMM dot interesting. Okay, sorry, keep having this annoying problem that we forget that we don't have access to the type. Now then, PMM index names. And the feature model is const out by reference feature model context feature model. That probably is by ref, I guess. So these are the okay, slight problem here. Okay, right, so at this point in time, what do we have? We have a feature group. Right, so the problem here now is that we copied a whole lot of stuff that's probably not static. Now we need to do the ugly job of statifying all of these guys. We started making all of our transforms static without really thinking too much about it. And it kind of made sense at the time, to be honest, but perhaps it's something that requires a bit more reflection, I think. Sometimes it's useful to have some state. Right, let's try to clean things up a little bit here. I always find it difficult to find the right shape for indentation. We have to desperately move to Clang formats. Just haven't had time to do that. But it is quite annoying to manually be faffing around this sort of stuff. Right, so at this precise point in time, we should be reading all of the features. And if all's gone according to plan, we should at least not break. It didn't. Well, presumably this means we're looking for a feature that doesn't exist. And we are. So that's exactly what I mentioned about C#. So now we need to be very careful here. We need somehow to distinguish between features that should exist and features that don't exist. So I wonder if there's like a try get by name. artifact. So this will create the whole feature group. Feature group has a top level inclusion required. So then we go through each archetype. Right, so we need some kind of query here, really. And in fact, to be honest, I think that's fine. What's not so fine is once we get into the PMM. So we should probably do something like s.try get by name. Now, what does try get by name do? I wonder. Excuse me. Let's have a look at this method. It returns a boost optional, so let's just do something like const auto o is equal to try get by name. If not o, continue, because we know for sure there's no point, and we know they're all going to come in clusters, so this will be O. And then we shall go and try. So, a bit of a hack, but again, remember this is one big hack anyway. So what we're trying to say is, we know for sure that in C++, well, we're basically trying to detect the very first feature. If we find the first feature, and then we expect the second to be present. If we don't find the first feature, then we just bombard. And this little trick works quite well. So, okay, so that solved our first problem. Now then, we can already create a directive group. We can. So, how much of the logic can we copy across now? Let's imagine. So we are here in an artifact, and given an artifact, we need to compute the directives for that artifact. We could probably see in this particular case we created the directive group repository up front for everything, and then we just go and query it. Now we changed that logic, so instead of that we just compute it on demand. The reason why we don't really need to compute it up front is because the include directory, the directive that you're going to do is just your own, so you don't particularly care about anyone else. So there's no need to go and compute the whole thing in one go. You can just do it as you go along. But that does mean the logic in the directive group needs to be copied across. Let's have a look. Oh no, actually I'm lying. This is where we're generating the directive group. It's all slightly confusing, really. That's why really we need to get rid of this logic. It's all very, very confusing. Well, I think, and I suspect I'm going to be guessing a little bit here, but let's just try to start copying some of this logic across and see what happens. Well, in fact, to be honest, before we even do that, before we go as crazy as doing all of that, let's do two things. First, let's just say physical add feature groups to legacy apps transform. Of course, nothing is broken yet, so we should probably just commit what we got. And the second thing we want to do is we want to say, can we please create a method for this just before things get completely out of control? So we need an artifact and the artifact probably also has a provenance, so we don't particularly care about that from the region. So I suspect we could do something like process archetype. Something very simple. Static void process artifact, sorry. And this could be something like entities artifact by reference A. And that would then mean, hopefully, that would then mean that we could get all of this guy here. And that would then be something like this. And we will just process the artifact. And A. And now observe, we can say that the logical name comes from the A dot. Okay, let's give it a second. Provenance. But logical. Now, what do we have there? Logical name. And the logical meta name will be a.provenance logical meta name. And of course we need a locator, so usual please supply us with the locator. Right, so all this is going to do is going to give us the breathing space we need for when we need to start adding all sorts of stuff into this method. Nothing should break just yet, hopefully. And that's the logical meta name. This is the artifact properties. I actually think this is equivalent to what we had a second ago. Our language server seems to be erroring quite a lot at the moment. Okay, just a slight error here. We didn't really mean the physical meta name, we meant the meta name. I mean, we meant the logical meta name, but the physical meta name. Okay. And now we just have to make sure we supply the locator, and away we go. Right, now then, so this is just preparation for the next step, which will be to copy across all that madness to compute the directives. So if you think about what we're trying to do at the moment is we're moving from a place where in the legacy code we had great amount of dependencies on the text transforms, and we were flipping things around. We were asking each formatter, each text transform as they were known before, to give us properties. Now we're trying to flip it around the other way and say, actually, we got a description of the metadata. Please use that description to compute whatever needs computing. And then we'll probably just commit this because I think it's probably good enough. Add method process okay types legacy graphs. That's what you see here. We do all sorts of very, very small commits just to make sure we didn't break anything. Now then, you're going to start very slowly so we don't get lost. So name is the logical name, we already got that. ID is just a logical ID, so we can just do something like ln.id. So let's just make sure the logic is correct. So we go to the artifact, get this configuration. Then, okay, first problem, we need a feature group. So if we just do const feature group fg, we need a feature group, we're probably going to need oh, actually we already got the feature model done there. So something like this, right? And CFG is going to be that chap. Okay, so up to now it's compiling. Now then. So, this logic here will be slightly trickier to understand. Not sure if we just copy everything in one go or not, but there we are. Right, so what we're trying to do then, we're going to say something like this. This is the relationship status. What we run here is so we're moving from one completely different object model to another. Yes, to keep everything in our head. So we need something like not relatable. Not relatable will be something like entities, relation status, not relatable. So that's equivalent to that. Now here we don't want to reverse the formatters. In fact, to be honest, we already are at the archetype level, so there is no need for a loop per se. We already have a PMN. We can get an archetype via the ID. Now the inclusion support type is const auto relationship status archetype dot relations dot status, and this will now be simply an RS. So we keep mapping this in our heads very slowly. The logic should be very, very similar, it's just that the data model is different. That's why it requires a bit of thinking. Okay, so if we have overrides, now we compute the inclusion path. Now then, how do we compute the inclusion path? So we probably don't really need that method for now. Let's just use this. So this will give us inclusion path. And then we create a directive group. Which we set to. So I don't really think this is all becoming a little bit confusing now because we don't really need a directive group actually. We just need to compute the inclusion path. So let's just go here and create path properties. So what we're trying to say something like pp dot inclusion path. Just the difficulty of keeping everything in memory, but I think we're going in the right direction. So compute to the primary directive. Okay, so now then this will be something like pp dot primary inclusion directive, and probably what we want to do then is to say something like this: const auto p right. So I think this is making a bit more sense now. Primary inclusion directive is this guy. We computed it. Now we don't have to insert anything because there is no longer a repository to insert things into. So that's no longer a concern. If this archetype location requires canonical archetype support, we need to map. Right, so that's where we need to be a little bit careful. So we are creating a meta ID builder here. And generating a canonical archetype. Right, that bit of code here really requires a bit of thinking. See if we have a using statement for this. No, we don't. We can have one. Make our life a little bit easier. So we're trying to create a physical meta ID. We have a facet. The facet is created. Right, so, okay, right, I think I know what we're doing here. We're trying to construct the canonical archetype for that facet. There will be some kind of... Right, so if we just go back to our traits. And this is the transform trait, so... If I look here for canonical archetype. So all this does is it adds this postfix here. It's not very nice, but we shall continue this logic. So all we need to do very carefully is to say take the facet name and then add to it the canonical archetype. It'd be nice if the builder could do that for us, wouldn't it, really? But let's keep things easy. And then we can generate a physical meta ID, which, to be fair, maybe we can just do that in the second step. So we could say, please add the facet with the canonical archetype and create me a physical meta ID. And then we need to understand what this insert inclusion directory is all about. We don't have an insert inclusion directory. Okay, so I think we are going to have a problem. Yes, okay, so this is actually not going to work, not going to be as simple as we thought it would be. The reason being that, if we recap a little bit, this is actually, in fact, what we're doing for time. I think we probably should pause this at some point in the near future. Okay, so the problem that we have at the moment is this. The existing code had a very, very complicated way of determining what header file to use for a given element if that element was not known. So say for example you're referring to an element called A or E, say, and we don't know if E is a class, we don't know if E is a enum, and we need to resolve that element or that reference to the element to a file that's going to be included. But because we don't have an idea of its archetype or its meta type, we don't know how to find it. So we created this notion where for types, for each type there will be a canonical archetype. One archetype that was, if you don't know who this guy is, just use that canonical archetype. And the canonical archetype is then used in these cases where you don't really know how to get to the type. Now that was all fine and dandy when we have one big container like this guy here that contains every single directive group, because we could just create an extra mapping here for the canonical archetype and everyone would be happy. That's not the case now, because now what we're trying to do is we're trying to move to a world where the artifact itself contains the information about the inclusion information. Now what's going to happen then is that when I'm trying to resolve relations and trying to figure out who maps to what, I need to locate certain archetypes inside of a container without knowing what specific artifact I'm talking about. And the current model doesn't really handle that very well. However, what we can do, which probably is even more sensible, is we could say we know from the beginning, we know what who's the canonical archetype for each given logical model element. So we could upfront just basically say, actually, every time you're looking for a canonical archetype, if your logical model element is X, then your canonical archetype is Y. And that's just a simple indexing, right? So we don't need to, for that logic to be scattered around every single container. We can just have that in a physical meta model, and then the physical meta model will then can be used to query for that. So what we'll do then is we just have to be very careful what we're doing here. We're going to say, actually, we don't care about canonical archetypes. We just compute the primary directive, and that's it. So so now we have the directive group. Now again, we don't really insert anything. Okay, something is not quite right here, because we've thought we should really have... Right, okay, that's correct. So this is basically the case where there are no overrides. Okay, which is fine. Else, there are overrides. And if there are overrides, what we just do is we create a directive group. And if that directive group exists, we then basically say pp.primary inclusion directory dg.primary. Of course, this should really be something like that. And pp.secondary is dg secondary. And we can just say this is the guy. Now, we don't really care about the canonical stuff, as I mentioned. So all we're going to do is this. We will have to worry about that later. I mean, we're just literally pushing the problem for the next bit of work, to be fair. But we hopefully just getting closer to the right the right model for the data. So to summarize, for each archetype, we first obtain the path properties. Then we make the top level inclusion required. we determine whether there's overrides or not. So here is the inclusion path. And now all we need to do, so hopefully what we're going to see now is that a lot of stuff here is all related to machinery that we don't need. So at this point in time we think that we got the inclusion directives under control. So now the only other thing we need to do while we're here, which hopefully would also help, is feature group perhaps, is the include guards, and the include guards will be done as follows. So if we go back to our file and path include guard expander, here we should have somewhere okay, as a header guard factory. I don't really think we need one of these. Let's have a quick look at what this guy is doing. I suspect it will be something very trivial. Yeah, so I think what we're going to do is well, be fair, it's very self-contained. I'm actually going to propagate this guy. I think it's fine. It's very self-contained. So right, so before we get involved into any of that, let's just make sure that we can run this thing without breaking the world. So what we're expecting it, okay, doesn't even compile. We seem to be dumping something to the stream, logical ID. Where is this logical ID, I wonder? Probably this guy here, I think. For some reason he makes it a bit slow, man. So it's one of the annoying things about LSP. It doesn't seem to detect template errors that well. So sometimes you need to let things break. Okay, 2 inclusion directories. So we seem to have missed one method. Fairly trivial one. And that's static. Right, so do we have a string stream? We do. Okay. So at this point in time we're computing the inclusion paths and we're computing the directives, but of course okay, now the reason why this is crashing is actually because the configuration is not set. I was expecting this to happen. If you remember, we had the note somewhere. Oh, we forgot to clock. We started around, well, we recorded for about an hour and 43 minutes. Probably started about 2 hours ago. So 1400 maybe. What was I saying? Yes, so we had recorded that the region configuration was null. Now that was very peculiar. We didn't really know why that was the case, but I suspect this was causing the problem here. Excuse me. So let's try to understand what's happening here. So if we go back to our projector, and if we look for configuration, so you see here that we are quite cleverly copying the configuration from the element to the region, which is good. But I think what we're not doing, at some point we're going to create an artifact. Here we are. I'm sure we're not going to find any more references to configuration. And what we should really have done is to say around here, a configuration is equal to r dot region dot configuration. I thought we had the region. PR. Now the reason why I'm going to the region and not the element, I could have gone to the element, but I definitely want to make sure that the region is being populated. So if there's anything suspicious happening with the configuration at the region level, I want to know. I mean, we don't necessarily need to be copying this pointer all over the place, really. We could access the region. It just makes life easier slightly. Right, that's good. So let's solve the immediate problem. Okay, so could not find configuration for archetype Dogen.main. Okay, now the reason why we're not finding configuration for archetype Dogen.main is because Dogen.main does not require inclusion. So let's have a look at where that could not find configuration is coming from. Archetype properties for archetype. That's puzzling actually. Would not find configuration for archetype. Okay, I'm not quite sure why this is. Could not find configuration for archetype. So asking for this. So when we create the path, oh, actually, this is no, actually, this is very misleading. We should not really be touching any of this code. So I'm not sure why we're getting this error. Because at the end of the day, we haven't changed the configuration. That's very puzzling, actually. None of the work that we've done should have affected the existing code. Unless we've done something really silly. Could not find configuration for archetype. I think that this naming is actually very, very bad, because of course that's really not what it means. It's not configuration at all. Let's try to make this a little bit more explicit, really. Meta model properties, archetype properties. So really what we're trying to say here is missing archetype properties. Right, and then could not find properties for archetype. Okay, that's the first thing we'll do, just to make the messages a little bit clearer, because immediately I was thinking the problem was with configuration itself. It is actually not a variability issue, it's just we seem to have misconfigured the model somehow, misset up. Okay, that's good. Now then, let's just see what we've done that could have possibly have broken this, because don't think so. All of the code that we added, I wonder what would happen if I just return here. So all the code that we added should not have affected the way that we were computing the full path. And if it did, then we did something without really meaning to. Right, see, something really bad has happened here, because we didn't really expect to be calling that method again. So let's again understand how we could call that method, because something very strange is going on here. So somebody is asking for the archetype properties for archetype. That's where we no. Okay, I think I know what's going on. Right, the problem is the locator internally calls that method, and we are calling that method for yes. Okay, right, fine. So what's happening? Okay, right, I get it. What's happening here is we are trying to construct an inclusion path. So we were a bit we do need the relation type really. What we want to do probably is something like let's just do something like this. Const auto rs a dot relation dot status, and let's just say something like if rs equals relation or entities relation status. So what we're trying to say is you must be either relatable or facet default. Because otherwise there's no point in continuing. So if we say something like if you're different from this and this is an and you're different from that, then return. We put a comment here so we remember. If the archetype cannot be involved in a relationship, there is no point in computing the relation paths. Okay, and hopefully that will then mean that we're not going to attempt to call the include path for types that can't possibly have an include path. Now this could still break. The reason why this could still break is because we're probably not using the relationship status anywhere else. So I suspect we got problems. Ah, this is very interesting. Invalid configuration exception. This is actually not even an archetype, so whatever it is that we think. Wow, this is rather puzzling actually. I think we're gonna have to call it a day in this video because we're already probably on to 2 hours and it's nowhere close to reaching any kind of end. So what have we done then? So if rs is different from relatable and facet default, well that means it cannot be part of a relationship, so there's no point in populating all this stuff related to relationships. That would make sense. What is slightly confusing is, go back to where we were a second ago, which is here. So we think we're asking by archetype. Okay, I think I know what's going on here. It's simply that when we're trying to calculate the inclusion path here, we're using the wrong thing. Okay, so let's just think about this for a second. What are we talking about here? What is ID? And this is why we should really be careful with these names. Don't really like ID as a name. Right, so it's a logical ID. So what we're meant to do here is to say PMID PMN.ID, and I do not want ID per se by itself anymore. because we don't really know what ID we're talking about, and then before you know it, we'll be confusing logical IDs with physical IDs. I mean, it's also another reason why we have types, and the type system would have picked that up were we not unpacking the primitive. Right, so now, what is the next error? Okay, now we seem to have types without an ID. And that is even more worrying. Right, let's just put some logging here. I think we probably should just put this at the very top. So started processing. Right, let's just do something like this, and let's sadly we're gonna have to go back to our tests. I think any of the tests in the code generation chain will probably be enough. So say we take variability here, we do some logging. Right, this is clearly where we start finding the problems. Really, it's possible so that we are modeling something incorrectly. It looks about right. Right, so here we are. So let's just look at what are we trying to do. This is probably just inconsistencies in the way we're setting up the meta model. So starting processing, so we're trying to process ODB options. Then we move over to C# types class, but the problem is we're lacking, we should be inside of a region. So if you think about this, we're in the region, and so what we really want is something like so if I just say something like region.provenance dot logical name, and here we can say ln, well, lmn, logical meta name, logical name. So in other words, what element are we processing at present? And starting processing logical element. Oh, start processing region for logical. Started processing region for a logical element. Okay, this is quite a long thing. It needs a bit smaller. Start processing region for logical element, and that is going to be not that, but ln dot id dot value. Okay, and now we can then say processing archetype in that region. Okay, so hopefully what this will do is it will locate us in the logical physical space. Where are we? What are we trying to do? And then that's going to tell us, was this chap that doesn't have its identity filled in properly? So so these are all archetypes. Right, here we are. So no, it's still an archetype. So where's the logical element? At some point we should really have a logical element around here. Let's look for region. Okay, here we are. So we're trying to process the region for logical element stood vector. First thing is class. Element's name is class. So all of this goes well. But then when I ask it for its archetype, which we seem to have filled in very nicely here. I'm not entirely sure how we managed to have an empty archetype. It's quite disappointing, really. So here we've got the ID. The ID is the archetype, and maybe we could probably say something like this, really. Now, why did the PM ID not work? So as you can see here, we clearly have an archetype, but we seem to well, where could we say could not locate archetype? So when creating a directive group, right? Okay. So when creating a directive group, oh, okay, that's very interesting. That shouldn't have happened. But clearly what we probably want to be saying as well here is probably something like right. At least this will give us some kind of clue. I think we probably removed the details inadvertently. So reading its dot value here. Right. So we need to understand why it is that we're not generating the correct feature group for this archetype. Because it's a C# type. Okay, cool. That's not a problem. We just need to make sure that in cases where we can't find, first let's just rename this to the right name. So let's call these archetype feature groups, and then let's just say well, actually now we don't really want to throw. We want to probably say something like, let's just see how many places are we using this missing archetype. Hopefully just the one place. Yes, okay, so what we want to do then is to say if we can't find it, then just return an empty directive group. In fact, for good measure, we will continue to log as debug. Which is fine. What I don't fully understand is why are we still looking for, actually, to be honest, no, let's just change this logic again. I think we're missing something here. Okay, so what's happening at the moment, just to recap, is we seem to be looking for a C# archetype. Now C# archetype don't have inclusion directives, so that's fine. Question is, why are we doing that? Because if you remember, we tried to be clever and we basically said basically said, well, if you're not relatable, then don't of course, but they still have using directives. Okay, so that's fine. All that's happening here is because we're trying to merge C# with C++, the logics were very, very different when we did this originally. And now it's very difficult to understand what needs to exist for both cases. So we're trying to shoehorn in the C++ use case. And the C++ use case contains a set of features that were specific to C++. These features won't exist in C#. So we need some kind of quick win here that enables us to handle both scenarios. And probably the right thing to do, in fact, is to go back to where we were. And yes, now that we understand what we're doing, I think we should be able to say, yeah, fine, missing archetype goes away, and or no, sorry, keep going backwards and forwards on this. What I meant to say is missing archetype can stay, but where so we'll probably just go for debug or trace, and instead of throwing an exception, we just return nothing. So this now will handle the special case of C#. And in C# when we loop through, so in C#, basically in the past we segregated the code generator into two processing pipelines, one for C#, one for C++. And that was fine, it worked for what it was supposed to do. However, now we're trying to merge these two processing pipelines, and what's happening is we're looking for C++ features in C# archetypes and vice versa. That's just not going to work. So what we need to do is we need to relax some of the checks that we had in the past, because those checks now are where we'd expect things to break. They could possibly be correct. It's just that they're referring to types from a different backend. So I think that's fine. So what have we achieved then? We've managed to now compute the directives for all artifacts in the model and take into account the features and overrides. We will do the header guards. That probably we already are 2 hours into it, but I think we can do the header guards in this video because it's just a simple thing to do, and all we need to do is to add the header guards here. And I think once we got that, we then have almost all the bits and pieces needed. So and then after that we can return for another video, which will be the inclusion processing. So first time is just to compute the directives and the relationships. The second part, which is much more complicated, is to then say, okay, now that every single element in the model has got their directives computed, give me the relationships between the different model elements. And that's actually much more complicated because the way that we used to do that before is we used to ask each text transform for that data. Now what we're saying is all that information is in the has to be encoded in the transform itself, and we won't be able to do this in this transform, the legacy transform. We need to create a second transform here because it's going to be a very large transform. So we just create a legacy inclusion transform here, and that job of that transform is going to be to take these directives that we just created just now, the directives that we got here, primary inclusion directive, secondary inclusion directive, you take those guys and we will compute for a given type what its includes should be. Interesting enough, I don't think we have. Okay, so the inclusion dependencies, yes, in properties. So the legacy inclusion dependencies transform will be the next thing to do. That will be actually quite a difficult thing to do because just for explanation, we'd have to go to every single formatter and we have to extract this bit here, and then we need to rework the builder. And once we rework the builder will then obtain the inclusion directives. And in fact, to be honest, it may even make sense to somehow the builder will have to locate the right archetype, extract the directives, So perhaps it should internally, I mean we're going backwards and forwards a little bit here, but perhaps internally what the builder will have to do is it will have to contain something like this map here, because it will be looking for a given logical ID and in a given physical representation, which is what the string represents, what are the directives for it. So it's actually looking for logical physical points in a map, in a space. And that's not actually very easy to do right now, because the space is not organized by logical physical points. It's not designed for that. So you will end up having to then do a search. So yeah, that transform will probably have to, as a first step, we'll probably have to organize this space with all the dependencies in the right shape. And then, in fact, to be honest, we don't even need a builder for that. We could just have that internal to the transform as a precondition, first step. And then we can do the loops for the builder like this. Because what these loops do every time we do an add, not these adds, but add biological name, it will determine the correct header to use. So this is all very complicated, but hopefully it will work. Righty, and now I can imagine why it was so hard to. We were trying to do this refactor in one step. I mean, it's difficult to do this in multiple steps. We were trying to do maybe about 5 steps in one go, moving to a data-driven approach just immediately, and that was actually extremely difficult. This is already proving itself quite complicated, so you can imagine. Right, so we're just going to commit this now, and then we can return. So let's just do a few of these commits. So orchestration, copy configuration to artifact, doing projection, and we don't really care about that one. This guy here is, well, actually make sure that everything is green. Code generator is indeed generating what it should be generating. Should have reverted that change to tests, because it makes everything slower. Right, as you can see, everything's fine. So we can just basically say something like more work. So work on adding directives to legacy paths transform. And whilst it's not exactly perfect, it's not far off. So okay, so I think we're just going to call it a day now and return at some point for the next iteration of this work. Thanks for watching.